Assalamualaikum. This is the task one of section B, in which we have to uh, train the models, two types of model, the random forest and standard stochastic gradient descent model. Uh, so here we're going to start. First, in first cell, I've I've imported the important libraries I need for this task. Then after importing the libraries, I fetch the data. I'm using this dataset. There are several datasets, but I'm using for this task the 784 one. The reason I've used this is because in books they have used it, so that's why I've used this. After fetching the data and converting the data type of the target variable, I just to see the shape of the how our data looks and the amount of columns and rows we have. I ran this code. After this, just to preview how our images look like, I have written this code of matplot for to plot first six images of the digits. After after plotting the images, I uh, split the training set and the test set. So, as I've been told, we have to use 60K images for training and 10K images for testing. After splitting, uh, I trained the stochastic gradient classifier by this code, and then after that, I've trained the random forest. After training both of the classifiers, I've written this code to predict the on the test set and print confusion metrics and classification report. So this is for random forest, and this is the confusion matrix. This one, and here is the classification report from here to here. Then this is the classification report and confusion matrix for stochastic gradient descent. After that, as it was told, we have to visualize the common misclassifications. So here is the code print the to print the common misclassifications by matplotlib. Then after that, I've hard coded these common errors, what I felt are the common ones. Then I called the function I've made above for plotting the misclassifications for both random forest and SGD. So here are the outputs of the common errors, and here basically I've printed only 4 to 5 photos. Here are the three. Here are the misclassification for 3 and 5 for random forest. This is for 7 and 1. And this is for 9 and 4, and then this is for SGD and three. How SGD is telling that it's misclassifying 3 for 5. Then the 7 for 1, 9 and 4. After that I've looked up for the improvement, and the improvement I thought is that I should augment the images. I should try to rotate and shift them a bit, and then try whether my model performs better or not. So here is the function for the augmentation. in which we are reshaping the image in in the way MNIST dataset takes 28 by 28 from array. Initially, it was an array. It's taking an array. Then I've converted it to 28 by 28. Then after that, I've rotated the image on random angles of -10 and 10. And then the same way I've shifted the pixels on random values from -2 and 2. And it will rotate and shift randomly between these values. After that, I've I've again flattened the image and then appended it into the original dataset. This is the uh, call for like breaking call. After it uh, have done augmentation on maximum samples, which I've taken as 10,000 images, it will break. Like it will get out from the function. Then after augmenting the images and putting them back into the original data set, I've retrained both of the models on the augmented images, and this code here is saving the model by joblib, and these are the classification report and confusion metrics for the retrained model. And then this is the same way I've done it for random forest. I've retrained it and saved the model for by through joblib, and then these are the outputs for classification report and confusion metrics. Then here, this is the code for Gradio. Here I'm importing the libraries I need. Gradio for the gradient interface, NumPy to access the images, PIL to basically to change the images according to the our need, basically to edit the image, I would say. Then I'm loading both the models I've saved in the previous code. Then after loading the models, there is a function for predict digit in which we are doing the same thing for like resizing the images, normalizing it by into zero and ones by dividing it by 255, and then basically it's a pixel. Pixels will get zero and one. Then reshaping the image, and then this is the if statement. If from interface the user chooses random forest, then this code will be run. Else, this code will be run. And this is the code for Gradio interface, and the we have to run it by on terminal by this command python app.py. After running it, it will show this local URL, and to run it, I'll follow this link, and it will open like this. Then just to check it, just to show how it will work, let's take this picture, and I select. This is the handwritten photo I've taken, and let's suppose I select SGD, and it predicts it's 3. Then let us try on random forest. It is predicting 0 because I think the model is not trained as good, and it's misclassifying the prediction.